Hello, my name is Khairul Hakeem bin Hamli. I am from kelas DEE2A, nombor metrik 20 DEE 24F 1050. So today I will present about practical work 2, chapter 2, diode. So in this practical work, our objective is to able to construct the circuit of half-wave rectifier using multimeter to measure voltage and current in the circuit and trace the input and output waveform of half-wave capacitor circuit using oscilloscope. Learning our uh, in this practical work, our learning outcome is able to construct the circuit of half-wave rectifier, able to use oscilloscope, trace the input and output waveform of half-wave rectifier circuit, able to measure voltage and the current in the circuit using multimeter. So this is our formula. Our important formula is the root the root mean square, which is VRMS voltage is given as VRMS equal to V out over uh, square 2 cos punca kuasa 2 for half wave rectifier. The average voltage for DC voltage. So the next one is V average, which is mean V average equal to V out per pi, where is V out equal to Vp minus diode. So for the current is I average equal to V average per Rn. So for our procedure and safety precaution, so first of all, we need to connect the circuit as shown in figure 2.3, which is from diode uh, from the power supply to diode, diode to LED, LED to resistor 1K, and come back to the power supply. First of all, choose the step transformer 12 volt and 0. So uh, from the socket, we need to use the transformer first, and then the supply from transformer go to diode 1, LED, RL, and back to the transformer back. Second, next one, using an oscilloscope, determine the input AC waveform at point A, B, and output DC waveform at point C, D. So, before you determine the input AC waveform at point A, you need to calibrate the oscilloscope first. So, and then you put the value in the oscilloscope. Next part is draw the input and output waveform and record peak voltage. So if you will get the result, and the result you need to draw at the table for the next slide. So next one is calculate VRMS, V average, and I average. Record the value in table 1. So first of all, uh, you need you need to search the V peak, which is V peak is 5 volt. The according to the result that I get, volt per division is 5 volt. VPP is 38 volt, and VAC is 12 volt. So this uh, this result you will get by using the multimeter and the from the oscilloscope. So the waveform at point A and B, it will full sine waveform, which is a complete waveform. So VRMS, we need to find the VP first, which is VP equal to VPP, V voltage peak to peak per 2. So 38 per 2 equal to 19 volt. So next step, we need to find V out VP. VP VP minus the silicon uh, jenis diode, which is silicon. The value of silicon is 0.7. So uh, we need to minus 19.19 minus 0.7 equal to 18.3 volt. So for the VRMS, uh, the formula is V out per punca kuasa 2 equal to, so dia sama dengan 12.94 volt. From the measured value we got VRMS equal to 12 volt. So the next slide, uh, we will see it. So the calculated value and the measured value are not too far. It's uh, nyaris nak sama value dia. So perbezaan dia cuma 0.94 volt. So dia sedikit error disebabkan oleh human error and the maybe the oscilloscope, the breadboard, or the transformer. So next part is by using analog multimeter, measure the VRMS voltage at point B, A and B and record the reading table. So when we use the multimeter, it to measure the VRMS voltage point A and B, we need to use uh, AC volt range, which is use the for the AC we need to use this this sign. So it's mean it's on AC volt range. So the V and straight line with the 3 dot bawah. So then next number 7, by using multimeter, measure the average voltage point C to D and record the reading table. So the point C and D, we need to use DC volt range at the multimeter. So V and the wave. So the sign is like this. Got V and the wave, which is mean it is DC volt range. So next part is insert a multimeter series with RL to measure I average, record the reading table. So for this part, we need to pisahkan buka laluan LED dengan resistor. So, negative LED multimeter, probe multimeter, positive probe and negative probe LED, negative LED dengan positive probe. Lepas tu, negative probe to positive resistor. Maksud dia macam tu. So, we will find DC ampere. So, this is a result that we get from by the that practical work. So, waveform C to D, we got the half sine waveform, which is not a complete waveform. We can see that it's only like this. You got two wave, not the complete wave. So volt per division is the same, which is 5 volt. Vp is 17 volt. VDC is 4.994 volt. So this we can get by using the multimeter. For the V average, we got 5.51 volt, which is a bit further from the measured value, which is 4.994 volt. I think because of the when disebabkan peralatan mungkin part-part mungkin sebab peralatan lama, so ia tak begitu tepat. So for the I average is 5.51 milliampere. It's far from the I average, but we got the value. So the discussion part, the DC output voltage observed in table 2.1. So the first question is, first of all, we need to calculate DC output voltage, which is mean V average. So the V average equal to V out per pi. So by using the given V out, which is 7.3 volt, V average equal to 17.3 per pi equal to 5.51 volt. The measure average voltage average is 4.94, which is slightly lower than the calculated value due to real world losses like diode voltage drop and circuit resistance. So it's mean the something problem in the diode or at the circuit. So for the VRMS, the formula for VRMS is V out equal to per punca kuasa 2. So we got 12.94 volt. The calculated value 12.94 volt is slightly higher than the measured value 12 volt, which is normal because it's hard to find the same value 12 volt because of the peralatan dengan alat-alat. The slight difference between calculated and measured value suggests a practical work loss such as the diode forward voltage drop, load resistance affecting the observed voltage, potential inaccuracy in oscilloscope measurement or probe placement. So mungkin disebabkan cara penggunaannya menyebabkan voltage lebih tinggi daripada voltage yang sebenar. So the next one is question 2. Discuss the DC output voltage observed in table 2.2. So in this part, you need to uh, reserve the diode which is mean uh, you uh, you reverse the diode from the positive diode, uh, tukarkan dia kepada positif pergi negatif, lepas tu negative diode pergi positive power supply. So the DC output voltage for half wave rectifier with load is calculated as V average equal to Vp per pi. So we got 5.51 volt. However, the measured voltage average is 4.94, which is slightly lower than the theoretical value due because of the diode forward voltage drop is 0.7 for silicon diode. Other than that, load resistance impact. Lastly, measure increases all circuit loss. So it maybe the things are not too good. So for question 3, discuss the DC voltage observed in table 2.2. So from the table 2.1, half-wave rectifier forward bias diode, which is Vp equal to 17, VDC for 4.94 volt, calculated average, voltage average 5.51 volt, current average 5.1 milliampere. So the key observation is the diode allow only the positive half cycle of the AC input to pass through, rectifying it into a pulsating DC signal. The DC output voltage is relatively low due to diode voltage drop and the absence of filtering capacitor. For the table 2.2 reverse diode configuration, diode block current, which is uh, reverse bias diode. In this case, the diode is reverse bias, meaning it does not conduct. So the current didn't go through well because uh, the, the diode block the current to go. The expected DC output voltage should be close to 0 volt as no significant current flow through the load. If a small voltage is observed, it may be due to leaking voltage in the diode or oscilloscope probe interference. So, uh, so, so from the theoretic, uh, uh, from the theory, uh, the the voltage should be zero because there's no current go through through the diode. So it need to be zero, but in our practical work, because we didn't get the zero, maybe because of uh, leaking leakage current in the diode. Maybe the diode is harm or something. So for question 4, discuss the operation of half rectifier. Operation of half wave rectifier. A half wave rectifier is a circuit that converts AC alternating current to DC direct current by allowing only one half of the AC waveform to pass through. It consists of a diode, a load resistor RL, and AC supply. A positive half cycle, which is forward bias. During the positive half cycle at the AC input, the anode of the diode, which is positive, to the cathode. The diode become forward bias, allowing current to pass through to the load resistor RL, which is the current will flow without blocks. It it mean the diode was forward bias. Next one is the output voltage follow the positive half cycle of the input, meaning the diode's forward voltage drop typically 0.7 volt for a silicon diode. Next one is negative half cycle, which is mean a reverse bias diode. During the negative half cycle of the AC input, the anode become negative relative to the cathode, so it will change the position. The negative change to positive, the positive change to negative. The diode is reverse bias, meaning it blocks current flow. As a result, no voltage appear across the load during this half cycle. The output remains at 0 volt during this period. So for the conclusion for this practical work, we learned about this experiment successfully demonstrate the construction and analysis of half-wave rectifier circuit using an oscilloscope and multimeter. We observe the input and output waveform and measure voltage and current value. The result confirmed that the diode allows current flow in only one direction, converting AC to DC. Reversing the diode shows that in reverse bias, no current flow and no DC output is produced. This experiment highlights the diode's role in reflection, rectification, and the important accuracy in circuit assembly and measurement. So in this particular, we got a bit error, which is mean when the reverse bias it needs we we must get 0 volt, but in our practical work we got the value. So something wrong with the diode and the connection. So that's all from me. Thank you.